This is Brian Putt. Today I want to talk to you again about the visualization of valued information for making better decisions. The real issue is, how do we explain this to our decision makers? I've talked about using the Blackgold evaluation before, and this time I've taken a relook at it and framed the problem slightly different. So let's get into it. Decision makers often have difficulty understanding the value of information. I know I've had examples where we've done the analysis and then the decision maker, despite the evidence, said, no, I don't want to do that. I can't afford a loss on gathering information. DMs may want to gather too much information because they really don't want to make a decision. Or they know what they want and therefore they don't want to gather any information. Let's just get on with it. So how can the value of information be better explained to those decision makers to improve decision quality? Let's use this case study to understand the graphical way to present value of information. Blackgold Petroleum buys petroleum products under a long-term market-related price contract and sells those products to a customer at guaranteed prices. But recently, the purchase price of the products has increased, resulting in a loss to Blackgold Petroleum when selling to the customer. The contract has a provision where they can reduce the supply of products to the customer by 10% due to circumstances beyond the company's control. This would save Blackgold $480,000. Now, if Blackgold were able to sell the products purchased at the current market price during the lawsuit, they could realize $420,000. Further, they would not incur a loss selling to the customer. Now, the issue is that if Blackgold's customer sued them, 40% chance, there are three possible outcomes. Blackgold could win the lawsuit. They could incur normal damages of $1.4 million or double damages of $2.8 million. Probabilities are shown here. And if Blackgold lost, they would likely have to pay additional court charges of $100,000. So what are the focus decisions of this case study? Should Blackgold withhold 10% of the petroleum product from the customer? Was the value of researching similar cases in the past and obtaining information about the judgment? In other words, what do they typically award? The cost to do that research is $20,000. They can also research the customer. What is their propensity to sue? And that would cost $10,000. So either one of those research studies worthwhile? That's the question. Previously, I have done videos where we assumed that the do-nothing case, not invoking, there was a loss of $480,000. In other words, in previous evaluations, I was down here and a minus 480 in the do-nothing case. In this evaluation, however, we take the do-nothing case as the reference case with the value of 0. So in this case, our value is 0. And this is probably appropriate because if we don't do anything, we're going to lose the $480,000. So that becomes our reference case. And it's very important in defining the value of information to understand what is your reference case. And it really shouldn't be the worst case scenario. It should really be, what is the most likely thing you do without information? So by invoking, we save the loss of $480,000, and we also gain the $420,000 for a total gain of $900,000. But this doesn't consider the potential for a lawsuit and having to pay a penalty. So what is the value of information? There can only be valued information if there is a change in decision policy. If I make the same decision as in my reference case, I don't change the decision, then how can the outcome change? Information doesn't change the underlying uncertainties that I've faced. It only gives me information about those uncertainties. Information can be either perfect or imperfect. If we have information on the outcome of a lawsuit, how will the decision policy change? In other words, I need to find my decision policy based on the results of that information, whether it be perfect or imperfect. Let us assume for the lawsuits that if the indicator was to win, we'd obviously invoke. If it was going to be normal damages, we would invoke. If it was going to be double damages, we would not invoke. In other words, we're really avoiding the real downside of a lawsuit. And for the customer, we assume that if the customer is not going to sue, then we might as well go ahead and invoke. And if they are going to sue us, then we have to consider what is the chances of a bad outcome in the lawsuit. So all those considerations need to be considered in the evaluation. So perfect information versus imperfect. We need to assess these chances that the assessments are accurate. Once again, there's perfect and imperfect. So in a perfect world, perfect information world, the reality of the customer is no, they would not sue us, and therefore the indicator would be no, 100%. Or yes, they would sue us, there would be 100%. In the case of the lawsuits, the realities are 0, 1,400K, 2,800K, and I've shown that this is the diagonal here of 100. In other words, if we would win, it's a 100% chance. This is perfect information again. But perfect information is rarely available. So what does imperfect information look like? Well, we're making some assumptions here. And so this is subject to sensitivity analysis if you wanted to do that. But we've said for the customer, if reality was he was not going to would not sue us, there's a 70% chance we'd realize that, and a 30% chance we would think he was going to sue us. And if he was going to sue us, we would believe that 80% of the time, and 20% of the time we'd be wrong. And with the lawsuits, realities are shown here, and the indicators are here. And so we have, if we're going to win the lawsuit, we're going to see that 70% of the time. There's 30% of the time we would think we're still going to lose in various amounts. And on the high side, double damages, we only see that 60% of the time. So 40% of the time, we could be wrong on that one. We're going to use these tables to first sample reality and then sample the indicator. We do not have to invert these Bayesian matrices in doing simulation. From a modeling practice, we simply sample from reality. And once we've sampled from reality, then we can sample from the indicator. And the decisions we make are then only based on the indicator and not the reality. Reality then evolves, gets revealed after we've made the decision. So what does the strategy table look like? Well, we can do nothing, which is to not invoke. We could invoke all the time. We're going to get information on the customer. So maybe we would invoke. So we're going to get the information, but we're not going to get the lawsuits. And we can get information on the lawsuits. Maybe we would invoke. No information on the customer and information on the lawsuits. And then we can get information on both. So that's 5 cases. However, as I worked through this problem, I said, I'm not really considering the full scope, the total frame that I could be considering. Remember earlier on, I said, if it was a normal judgment against us, we would invoke. But what if we didn't invoke? So I expanded the strategy table to include those 2 cases. So I added over here, invoke the mid indicator, that nominal indicator. So the lawsuits is yes, we're going to get the lawsuit information, but we're not going to invoke with the mid indicator. And certainly if I do both of them, I will not invoke with the mid indicator. So this gives us 7 different alternatives, different strategies to evaluate in this particular evaluation. Now I utilize multiple experiments in SIPmath. This is available in the enterprise version. And I think this multiple experiments is underutilized in SIPmath. It's a very powerful tool because I can run multiple simulations very easily. They run automatically. I get the results all out at one time. So in this particular case, I set up a multiple experiments with my seven different scenarios, referring to the strategy table. And these correspond to what we just looked at. And from that, this is imperfect information. I get the expected values for the MPV, in this case, MPV here. And because I have these represent full distributions, I can then calculate the probability of losing more than $2 million, or I can look at the chance of having a positive outcome. And then I can also look at other value metrics like how often do I invoke? So let's look at those 7 strategies. How often do I invoke? Well, if I don't invoke ever, it's a 0, right? And if I always invoke, it's 100%. Then this shows the perfect information and the imperfect information. The observation here would be that imperfect information invokes less often because we're a little bit more cautious because we're not certain about it. However, when we get both information on both the customer and the lawsuits, we're then a little bit more aggressive and we can invoke more often. And when I don't invoke with the nominal settlement, I clearly don't invoke as often either. So it just kind of gives you a flavor for how this works. Here is the value relative to doing nothing, relative to 0 now, because here's the do not invoke, which has a value of 0. These are the expected values here. And if I invoke, I have a 313, and you can see the values here for imperfect information. These look very much like a stair step rather than a continuous distribution, and that's because we don't really have any continuous distributions in the model right now. But we could add uncertainty to the information costs or the court costs, and we could add uncertainty to the damages award. So it's $1.4 million, and it's a plus and minus certain values around that, and it's a $2.8 million with a plus and minus around that. So that could add to it and make it much more smooth. Now, I could take all those graphs I just showed you and put them together in this one graph. But just because you can, you shouldn't necessarily do it. It needs to be adding value to the decision maker so he can easily understand it. If I have to spend 5 minutes explaining it to him or them, it's not a good chart. So let's look at this a little differently. Let's look at this as a cross plot. And let's plot the EV MPV added versus not invoking. So do not invoke is down here at 0 versus the chance of a positive outcome. And now we see our 7 cases. Now, some of these strategies are dominated. For example, why would I ever just research lawsuits when I could invoke and I get a higher NPV and I get a higher probability of a positive outcome? The same for these other 2 here. They dominate these cases, these 4 cases here. Therefore, we want to focus on these 3 strategies. What I've done now is simplify the chart to show only 3 things. I've shown the 3 cases of invoking, doing both, invoking with the nominal outcome, and doing both researches without invoking with the nominal. You can see that. Now, this chance of a positive outcome is a little bit misleading because I said positive. So that means to the extent that I incurred costs to get the research, it gave me a slightly negative number. So as I look at this green line here really has almost a 90% chance of being positive if I assume this line right here is either 0 or 0. So if I said greater than or equal to 0, or greater than or equal to negative $30,000, which would be right now is the cost of my two researches. And this green line also has 373. These researched both without developing the nominal indicator for the lawsuits. So where does this leave us? Well, we don't know exactly. We have to defer to the decision maker because it's based on his risk preferences what we should be doing. So if you were the decision maker, what decision would you make from these three, recognizing these four down here are dominated by at least these two metrics? If you'd like to learn more about SIPmath, you can visit probabilitymanagement.org. You can read The Flaw of Averages by Sam Savage, and he has a new book out, by the way, came out within the last couple of months. I have many videos on the YouTube channel. You can look up Brian Putt, and it covers these kind of categories. And if you have questions around this video or any of the other videos, you can contact me at brian@putts.com. Thank you for watching.